sense again because I told you that an examiner does not have to tell you this. You have to also be able to see it for yourself because you can see that this is the positive x-axis and the point is on the positive x-axis. So even if they did not tell you that p is greater than 0, you should have known that, right? Because negative x values are on this side. On this side, you have positive y values by looking at the axis. So don't forget. Then they give you that the length of AC is root 15 units. Now, the first question says to us, we need to determine or calculate the gradient of AP. Do you still remember how we do that? How do I calculate the gradient of AP? Anyone? Right, in this case, because
Change
I
in
do have...
y over change in x.
Perfect. It's changing now over changing x because I do have the two coordinates of A and B. So I can say that the gradient of AB is equals to change in y over change in x, which is equals to yb minus ya or y2 minus y1 over x2 or xb minus x1 or a. Now we're basically just substituting m8b, which is the gradient of ab, should be equals to the y value of b, which is 0, minus the y value of a, which is 3, the x value of b, which is -2, minus the x value of a, which is -1, which is 1, sorry. Then now you find out that the gradient of AB becomes this, 1. Did we all get 1? Okay, perfect. So we know that the gradient of AB is equals to 1. So the gradient of AB is equals to 1. Now the next question says to us, show by calculation that P is equals to 2. Now P is a coordinate of C. Now, is there a way in which we can calculate the coordinates of P and show that there are 2? And the answer is yes, because we are told that this entire length here, this entire length of AC is equals to root 50 units. I think they said so. Yes, they said AC is equals to root 50 units. Right. So we told that this is root 50 units. And therefore, because of that, we can use the distance formula in order to show that P is equals to 2. Keep in mind that the distance formula works best if we only have one variable to solve for. So in this case, the only variable to solve for is P. That is why it's going to work best. And then that's technically it. And then now, how do we do that? Let me just do it on the next page. We know that distance is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared, right? In this case, let's go back. What is it that we are told? We're told that the distance is the square root of 50. The coordinates of A, it's 1 is to 3. The coordinates of C, that's P is to -4, right? Just right here so that you don't forget. That's 1 is to 3. And then this is P is to -4. So now we are doing the substitution. Substitution is going to be D is equals to, sorry, we do have the distance. The distance is the square root of 50 units is equals to the square root of, it depends on us which one do you want to use as our 2's and our 1's. I'm choosing to use C as our 2's and A as our 1's. So substituting that means that x2 is going to be P minus x1, which is 1 squared, plus y2 is going to be the y value of C, which is -4, minus y1, which is 3, like that. Then now, the rest is maths, right? We can, so the square root of 50 units is equal to the square root of, this is going to be P minus 1 squared plus -4 minus 3. Don't forget the squared like me. -4 minus 3, that's -7. If you square that, that's going to be 49. And then this is going to be the square root of 50 is equals to the square root of, okay, no, you don't have to do that anymore. We can basically, it's all up to you. You can first remove the square root from this point or later, but I could just remove it later. The square root of 15 is equal to this. So now we're simplifying p minus 1 squared. Remember that, just to show you, p minus 1 squared, this is the same thing as p minus 1 multiplied by p minus 1, which is going to give us p squared minus 2p plus 1, if you simplify it. So this is going to be p squared minus 2p plus 1 plus 4, which was originally inside the bracket, right? And then 50 is equals to, we are simplifying what is inside the bracket. We have p squared minus 2p plus 5. I just added the numbers. That's the only thing that I did. Then from here, I can remove the brackets. You could have removed it earlier. It's all up to you. I chose to remove it now. This is 50 is equals to p squared minus 2p plus 5. Remember that when you raise to the power of 2, oh, yes, it's 49. Sorry, I don't know. The pen didn't write, and that's why. Okay, fine. It's 49. Sorry, that is 49. And this is 49. And this is going to be 50. And this is going to be 50. I don't know. I think the pen missed the first 9. And then I just carried on with that. But yeah, negative 4 minus 3, that's negative 7. When you square that, that is going to be 49. Thank you so much for noting that. And then we're going to say 1 plus 49, which is going to be 15. And then that is still 50. Right. And then now we are going to take, obviously we're going to simplify by taking everything to one side. So this is going to be 0 is equal to p squared minus 2p plus 15 minus 15. And then going to be 0 is equal to p squared minus 2p, because the two 50s are going to cancel each other because one is positive, one is negative. Then usually things make more sense if I do this. P squared minus 2p is equal to 0. There's nothing that I did. I just changed the position of p squared minus 2p. This is 0, right? Then from here, I can take the common factor. The common factor is p into p minus 2, and that's equal to 0. Then now I am going to solve for p. P is going to be equal to 0, or p is going to be equal to 2. But they told us that p has to be a number that is greater than 0. Therefore, p cannot be equal to 0. Therefore, p is equal to 2. And then that confirms what we were told. So they told us to show that p is equal to 2. Are we all clear? Is there a question? Something that is not really clear? I'm seeing thumbs up. So I guess people don't have questions. Right. So now, from that, we can now determine the equation of the perpendicular bisector of AB. So in analytical geometry, as I said, it's very important, one, to understand the terminology. Two, it's very important to make constructions, right? So in this case, we talk about the perpendicular bisector of AB, right? So there is a line that is cutting AB such that also it becomes perpendicular to AB. That's what this statement is saying. Remember, I told you last time that to bisect is to cut into two equal halves. So the perpendicular bisector of AB means that it's a line that cuts AB into two equal halves. At the same time, that line is perpendicular to AB. So now there should be a line like this. Let me just remove this. So a perpendicular bisector of AB would be a line like this. And this line is perpendicular to AB. And is perpendicular such that it cuts AB into two equal halves. So it cuts AB into two equal halves. So now there are two things that we can understand from this statement, right? I said to you, one, understand the fact that it's a bisector, meaning that it cuts the other line into two equal halves. So the line in this case, they said it's AB. So this is a perpendicular bisector of AB. So it's a line that one cuts AB into two equal halves. Two, it's perpendicular to AB because they said it's a perpendicular bisector, right? So we need to determine the equation of that line. That's what the equation said. It said determine the equation of the perpendicular bisector of AB, right? So now we are saying, how do I determine that? Remember that for you to determine the equation of any given straight line, one, you need to have its gradient. Two, you need to have any point on the line that you can substitute so that you can solve for C, right? So now at this point, we don't have any point that is given to us in this line that we're trying to solve or find its equation. So this line, we don't have a point. But we can actually calculate a point on that specific line. And if you can have a nice look at that point, I've highlighted it in red. Anyone who can tell me what that point is?
Midpoint.
What is? It's the midpoint of which line?
Line AB. AB.
Perfect. Yes. So it's the midpoint of line AB. How do I know? Remember that we said that this line is cutting AB into two equal halves. So the point at which that happens is at the midpoint. So it cuts the line at the midpoint, obviously, right? As someone had already said. Very good. So now we are saying if we can calculate the midpoint of AB, we will automatically have a point that is on the line whose equation we have to determine, right? That's number one. We are sorted with the point. Now, also remember, for you to solve or find an equation of a line segment, you need its gradient, right? So now, can we calculate the gradient of that line? That's my question. Do we know the gradient of the purple line? And the answer should be yes, because we know the gradient of AB is 1. And if AB is perpendicular to the purple line, what is going to be the gradient of the purple line?
-1.
Negative 1. Perfect, right? Because remember, we know that the relationship between the gradients of two perpendicular lines is that if you multiply those two gradients, you're supposed to get -1, right? So if the gradient of AB multiplied by the gradient of the line should be equals to -1, and AB is equals to 1, therefore we can see that this is going to be -1, right? So that's how we find the -1. So now it means that we need to do one last thing. Obviously, it's calculating the coordinates of the midpoint. Do you still remember how to do that? How do we calculate the coordinates of the midpoint of AB? Any midpoint, we add the two x values, divide by 2. We add the two y values and divide by 2. That's how you find the midpoint of any line segment. So for any line segment, that's what we do. So it means now the midpoint of AB is going to be what? Two x values, that's going to be the x value of A, which is 1, plus the x value of B, which is -2, all that divided by 2. You add the two y values, the y value of A is 3, plus the y value of B, which is 0, and that divided by 2. Therefore, you find out that the midpoint of AB is going to be, and then this is going to be -1/2 is to 3/2. Can you all see how we calculated the coordinates of the midpoint of AB? Remember the midpoint? Remember, the midpoint is a point that is halfway through the entire line segment. So that's why we take the two x values of the coordinates on the extremes, we divide by 2. We take the two y values of the coordinates on the extremes, we divide by 2. Then we have our coordinates. In this case, we have -1/2 is to 3/2, which is this point right here. -1/2 is to 3/2. That's the point. So now we can therefore move on to determining the equation of the line, right? So we are saying for the line segment that we're talking about, let's just use the space. We know that the gradient of the line is equal to negative 1. Why is that? It's because we know that that's the gradient of perpendicular lines. Remember, I said to you it's important to write down the reason as to why I was saying that the gradient of that line is negative 1. It's because we were told that this line is perpendicular to the line AB, and we had calculated the gradient of line AB as 1. So it means that the gradient of that line has to be negative 1. Then once we have that, we show again, you need to show on your write-up the calculation of the midpoint. You take the two x values, you divide by 2. You take the two y values, you divide by 2. That's the calculation of the midpoint. I'm just showing you how you would write it up. And then I think if I remember correctly, I don't. That was negative 1. That's 1 plus negative 2. 1 plus negative 2 divided by 2. And then this was 3 plus 0 divided by 2. Therefore, the coordinate of the midpoint was negative 1 over 2 is to 3 over 2, right? Because everything here has a mark, so that's why you need to do the write-up correctly. So now we get to the important part, which is determining the equation. Remember, our equations are always determined in the form. Let me just use a different color. In the form y is equal to mx plus c, right? So first things first, as I said, you substitute the gradient, which is negative 1. So this is going to be y is equal to negative 1x plus c, which is basically y is equal to negative x plus c, right? Then from here, what do? We need to substitute a point on the line to solve for c. What is the point on the line that we have? We have the point M, AB, which is negative 1 over 2 is to 3 over 2. The reason why we're substituting this point is to solve for c. Now we are saying y value is 3 over 2 is equals to negative. The x value is negative 1 over 2 plus c. Now this is going to be 3 over 2 is equals to 1 over 2 because negative times negative is a positive. 1 over 2 plus c, right? Then you take this to the other side. This is going to be 3 over 2 minus 1 over 2 is equals to c. And then when you punch your calculator and say 3 over 2 minus 1 over 2, you're supposed to be finding 1. Therefore, c is equals to 1. Therefore, the equation of this line is going to be y is equals to negative x plus 1. Is there anyone who is lost? Any questions as to how to determine that equation? I'm seeing a thumbs up. That shows me people are fine. Okay. So just remember the general steps of how to determine the equation of a straight line. Remember, you find the gradient, you find any other point on the line, you substitute it, you solve for c, then you write down the equation. That's the general step, right? Now, the fourth one is saying to you, write down the coordinates of D such that ABCD is a rectangle. Now, remember that no one told you that this is a rectangle, right? Now they are saying to you, okay, now we are telling you that ABCD is a rectangle. And I said to you guys, you need to read and study the properties of quadrilaterals because they're very important. This is an example of equation that needs you to understand that. So we know that properties of a quadrilateral, in this case, if we are told that this is a rectangle, we know that this here must be 90 degrees and all the other angles inside must be 90 degrees. So this is 90 degrees also. Actually, I should be asking you this. What are the other properties of a rectangle that you know? Because you are my lovely kids and you guys studied your homeworks and you studied these things. What are the other properties that you remember from what I sent you guys regarding a rectangle? Other than the interior angles being 90 degrees, what else must happen for something to be a rectangle?
Opposite side must be equal. Opposite sides.
Perfect. So opposite sides must be equal. So this side is equal to this one, and this side is equal to that one. What else?
Opposite sides are parallel.
Perfect. So the opposite sides must also be parallel. So this must be parallel to this, and that must be parallel to that. Is there anything else?
Diagonals are equal and bisect each other.
Perfect. Diagonals bisect each other. So I'm going to add a diagonal here. Another diagonal. So this is the other diagonal. Okay. This is not working nicely. Let's try one last time. Okay, it's just moving. Let's just do this and see what's gonna do. What the hell is wrong with that? Okay, it's acting up, guys, so I don't know. But like technically, what she was saying with the diagonals is that diagonals, we say they bisect each other, meaning that these lines cut each other such that this is equals to this and that is equals to that. That's what it means when you say diagonals bisect each other. So the lines cut each other such that that happens, right? Then now the question says to us, we need to calculate or write down the coordinates of D if ABCD is a rectangle. So this is a 2-mark question, which means that it should be really easy. And I think I told you last time, which way do I prefer you do this question other than the other way, because there is another way in which we can do it much more simpler. So I said to you, if a question tells you about diagonals that bisect each other, and you have to determine the coordinates of a specific point that you don't fully know, the best thing to do is to firstly find the coordinates of the midpoint, which is this green point here, right? Because we know that AC and BD share the same midpoint because they bisect each other, right? So they must share the same midpoint. So now, how do I determine the midpoint of AC? It's the same method that we did. So we know that for any midpoint, in this case for AC, we're going to take the two x values, which is 1, plus the value of p is 2, divide by 2, plus the y coordinates, which is going to be 3, plus negative 4, divide that by 2. Therefore, the midpoint of AC is going to be 3 over 2 is to negative 1 over 2. Do you guys understand how I calculated that midpoint of AC? Okay, so this is this point right here, which is 3 over 2 is to negative 1 over 2. That's the midpoint, right? And I said to you, these two lines, the line AC and the line that I've drawn in green, they share the same midpoint, meaning that that midpoint is also the midpoint of BD, right? And what did I say about knowing the midpoint and having to find other coordinates? So remember I introduced you or showed you guys these equations where I said the x value of the midpoint is equals to the x value of the 2 points. In this case, it's the x value of B plus the x value of B divided by 2. And I said similarly, the y value of the midpoint is equals to the y value of 1 point. In this case, it's B plus the y value of D, all of that divided by 2. So these are the equations that are very key in this case in terms of helping us how to figure out the coordinates of D, right? Because we have the midpoint. So let's, for example, let's start here. Let's remove this so that don't get confused. So the x midpoint is 3 over 2, which is equals to, do we know the x value of B? The answer is yes. The x value of B is negative 2. So we're going to substitute negative 2 plus we don't know the x value of D, all that divided by 2. Cross multiply, right? This is going to be 2 multiplied by negative 2 plus xd is equals to 3 times 2, that's 6. Then you're going to have negative 4 plus 2xd is equals to 6. And you're going to have 2xd is equals to 6 plus 4. Therefore, 2xd is equals to 10. Divide by 2, divide by 2. Therefore, the x value of d is equals to 5. Is there a question regarding how I calculated that the x value of d is 5? Do you all see how I used the midpoint to calculate the x value of d? guys? Okay, I'm seeing thumbs up, which is that people are fine. Okay. Now we're going to do the same thing with the y coordinates, right? So we know that the y midpoint should be equals to the y value of b plus the y value of d divided by 2. Substitute, what is the y midpoint? It's right here. That's negative 1 over 2 is equals to the y value of b is 0 plus yd divided by 2. Cross multiplication, this is going to be 2yd is equals to negative 2. And then you're going to divide by 2 on both sides. And therefore, you're going to find out that yd is equals to negative 1. So therefore, the coordinates of d are going to be equals to 5 is to negative 1. In conclusion, do you all see how we calculated the coordinates of y? Or is the equation? Okay. So last week, I showed you another method that you could use. In this case, you can see how it's, what am I saying? You can see how this is the 2-mark question. So if you don't want to go via the long method, although in grade 11, I would suggest that you go for this long method because most likely they will allocate a lot of marks for this. But now, just to show you, again, I need to remove a lot of things on my screen so that you can see this nicely. So I'm going to remove this. All of these things, I'm going to remove them because to show you nicely how this will happen. Right, so I said the other method that you can use is inspection, right? So this is how inspection works. So if 2 lines are parallel, I said to you guys, if 2 lines are parallel and equal, remember that we said that for a rectangle, opposite sides are equal and parallel, right? This only applies if the 2 sides are parallel and equal, guys. Remember that, parallel and equal. So what we can say is to use a method called inspection, whereby we basically look at how this point moves from here to here. Let me use different colors so that you can see how the point B gets to be A. So if you can have a nice look, you can see that, okay, you firstly have to use a certain, let me just use right. You firstly have to use a certain number of units going up, and then you have to use a certain number of units going to A like that. So just to check if people are with me, how many units upwards do I have to move from B to get to A? How many units upwards do I have to move from B
1.
to A? Perfect. It's 1 unit, right? I'm only moving 1 unit upwards. How do I know that this is actually 1 unit going upwards? You can see that the y value of B is 0. And then, well, why? It's not 1. Okay, it's not 1. So remember I said upwards, not to the right or left or something like that. Now let's try that again. So I'm moving from a y value of 0 to a y value of 3. How many units upwards am I moving?
3.
Perfect. It's 3 units, right? Just be careful around that. So it's 3 units. Now, how many units am I moving horizontally? How many units am I moving horizontally from B to A? It's still 3 units, right? Why is it 3 units? I'm moving from negative 2 to 1. So if I add 3 to negative 2, I'm going to get 1. So it's also 3 units. Do you guys see that? Can you see that I'm shifting the point B 3 units up and also 3 units to the right to get to A? Because I'm moving like this and moving like that. So I'm trying to get to A. So you ask yourself, how would I get to A? I would get to A by moving up 3 units and moving to the right 3 units. Then I would get to A. So now, basically, we do the first part in order to figure out how do I move up, how do I move to the right. So once we figure that out, now we're going to apply the same thing between C and D, right? Because remember, AB is parallel to CD. So whatever happens to AB happens to CD. It's the same method. So now we're going to again ask ourselves, remember that we had already calculated that this is 2 is to negative 4. It's the coordinates of C. So now you'd ask yourself, now, how do I move horizontally from C to D? I must also move 3 units, right? Because that's what happened between A and B. So this must also be 3 units, and this must also be 3 units. This must also be 3 units right here. So we can find the coordinates of D just like that. So if I move from 2 and add 3 units in this direction, where do I end up at horizontally? 2 plus 3?
5.
5. That's the x value of D. That's 5, right? Because I'm moving 3 units to the right horizontally. Now, vertically, I'm moving 3 units also. So initially, I'm at negative 4. So when I say negative 4 plus 3 units going up, what do I get?
Negative 1.
Negative 1, which are the coordinates of D. So you could do the first method, which is understanding how the diagonals work, or you could also do inspection, which is basically this that I'm showing you on the diagram. It happens only if the 2 lines are parallel, 1, if the 2 lines are also equal. If they are not, if they are neither, you can't do anything. Like, there has to be both conditions. They have to both parallel and equal. Is the inspection making sense? I hope it does. But most likely you will need to use the understanding of how the diagonals work in order to figure out things. So now the next question says, determine the equation of the circle passing through A, B, and C. This is a grade 12 concept. One is going to ask you to determine the equation of a circle. They will ask you to determine the equation of a circle next year, not this year. So that is a grade 12 question. Now the next question I was saying to us, calculate the size of theta rounded off to the nearest whole number, right? You must round it off to the nearest whole number. So now, what is it that we must calculate? Is there a question? I'm hearing someone speaking. Okay. So I was saying to you guys, we need to find the size of theta, right? Now, we are saying that there are multiple things that you need to kind of like notice or appreciate from the diagram in order for you to work your way to calculating the size of theta. There are multiple things. So you could maybe start by, this again is just a brainstorming moment just to show you how you would work around it. So we know that this is
Okay.
So we know that this is 90 degrees, right? Because we were told that this is a rectangle. This is also 90 degrees. That is also 90 degrees. And that is also 90 degrees, right? So now, again, as I said, there are multiple ways that you can look at it, right? Someone can say, okay, if I can calculate the size of, for an example, if I were to calculate the size of this right here, right, that is not a circle, right? So we are saying you also would appreciate the fact that this is also theta. Is there anyone who can tell me why that is theta? Why is A1 also theta?
Alternating angles.
Perfect. So you can see that theta is an alternate angle with A1, right? And you can see because they are parallel lines. These two are alternate angles, so that up there is also theta, right? And then now the rest, I'm sure, is clear. Why am I saying the rest is clear? You can see triangle ABE. Let me just highlight it so that you can see it. You can see this nice triangle right here. And having this triangle, we can use it to find the size of theta. How are we going to use it to find the size of theta? We do have the gradient of AB, so we can calculate the inclination of AB, which is that. We don't have the gradient of AC, but we can calculate it because we do have the coordinates of A and C. Once we calculate the gradient of AC, we can again use inclination to calculate the size of this angle. Then from then, we can basically find the size of theta. Do you guys see that approach? Is the approach clear? Okay, someone is saying yes on the chat. So basically, first things first, we need to realize the fact that A1 is also theta. Why is A1 theta? Alternate angles. That's one. Two, we need to realize the fact that we have AB, we have the gradient of AB, so we can calculate the inclination of AB using the gradient. Then also realize the fact that we have A and C, so we can calculate the size of E2. And then also, because of those two angles, we can use some angles of a triangle to get to the size of theta. Now let's do the write up nicely. Right. So we know what we've just said is that A1 is equal to theta, and the reason was that these are alternate angles because we know that AB is parallel to CD. Right? Don't forget to write down the reason. Now we are saying the next thing is understanding that the inclination of AB, which is B1, this is B1 that I'm talking about, right? So we know that the size of B1, we just rewrite like that. Okay. Okay. So we know that tan of angle B1 is equal to 1. Why? Because remember that we calculated that the gradient of the gradient, let me just do it like this, just to remind you. We know that the gradient of AB, we calculated it as 1. So therefore, tan of angle B1 should be equal to 1. This is from the equation. Remember that equation that we said, tan theta is equal to m. We are just modifying it by changing the angle because the angle in this case is not theta. The angle is B1 that we are working with. That should be equal to the gradient of AB, which is 1. Now, we're saying therefore angle B1 equals to tan 1, and therefore angle B1 should be equals to 45 degrees, if I remember my maths correctly. So now we have the first angle, which is this one right here. This angle is 45 degrees, like that. Now, do you still remember why I did not add 180 degrees in that calculation? Why did I not add 180?
The angle wasn't a negative angle.
Perfect. We only add 180 degrees if the angle is a negative. So because it was not a negative angle, it's a positive angle, I'm not going to add 180. Then now here we want to calculate the inclination of AC, but the problem is that we don't have the gradient of AC, right? So it means that we need to firstly work around calculating the gradient of AC. So we are saying, again, we have all the coordinates, so we can just calculate the gradient of AC as the change in y over the change in x, which is going to be the y value of C minus the y value of A divided by the x value of C minus the x value of A. Substitution, this is going to be the y value of C, which is going to be negative 4, minus the y value of A, which is going to be this 3. And then let me just do this. I don't need the brackets. Minus 3, all that divided by the x value of C, which is 2, minus the x value of A, which is 1. And if you punch your calculators, what do you get? What do you get?
-7.
Negative 7. Perfect. So now we're going to check if this gradient is making sense. And yes, the gradient is making sense because you can see that AC is a decreasing function, which is why it has a negative gradient, right? It's a decreasing function. So now, how do we use this gradient? Again, let's just firstly check what is the inclination. Now, just to check if you remember this, which one is the inclination of AC between E1 and E2?
It's E1.
E1.
It's E1, right? Perfect. So now we are saying this is going to be tan of the angle E1 should be equals to the gradient of AC. Substitution, this is going to be tan of E1 is equals to negative 7. E1 is going to be equals to arctan negative 7. Remember, I said you don't change anything, just substitute as S. What do you get when you say arctan negative 7?
We get negative
Negative 81,87.
81,86.
Sorry? Negative 81,
87.
869 something 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 something. Now, what do I do?
Plus
You add
180.
180.
Perfect. Remember, I said you must remember to do that also before, just to make everything balance out. But no one will penalize you if you didn't do that. So you just add 180. Therefore, E1 is going to be equals to, what do you get on your calculators?
98,13 degrees.
98.13 degrees. Perfect. So that is the size of E1. But which angle do we actually want? Are we looking for E1 or are we looking for E2?
E2.
Perfect. E2 is going to be equal to, it's going to be this, right? Remember, we said the one that is not the inclination is the one that is negative. So it means that E2 is going to be equals to 81.87. And the reason why, remember we said it's because of angles on a straight line. We said those two angles are on a straight line. So the one that is a positive is the inclination one. The other one that is not the inclination has to be the negative one. And that's why we said angle E2 is 81.87 degrees. And that's because these two are angles on a straight line. Now we come here and substitute that. This is going to be 81.87 degrees. We know that this is 98.13 degrees. 13 degrees. So now it's up to you as to whether you're going to use exterior angle of a triangle to solve for theta, or you can use some angles of a triangle, which basically says to us we do not need to calculate this, but just so people can see things. So we know that theta plus 45 plus 81.87 should be equals to 180. What is the reason?
Sum of angles of a triangle.
Sum of angles in a triangle.
Perfect. Some angles of a triangle. Now, this is C. So theta plus 126.87 is equals to 180. Therefore, theta is now equals to 180 minus 126.87, which is 53.13. But they said that we must round off our theta to the nearest whole number. So what is going to be our theta?
53.
Perfect. So theta is now equals to 53 degrees, right? Now that's it. Theta is equals to 53 degrees. And that's how you get your 5 marks. So again, I told you that remember that inclination is not always going to be you calculating inclination for one specific line. You might need to calculate multiple lines in order to calculate a specific angle that they're looking for. So just keep in mind that you very much might have to construct. And again, it's also important that you do the write-up nicely, like I did mine. Everything was written with reasons. Everything, you cannot use an angle that you did not qualify. What do I mean by qualify? You cannot use an angle that you did not say why is it that angle. For example, I couldn't have just used 45 degrees without showing the calculation for 45 degrees. I couldn't have just said, I'm showing the wrong thing. This is what I want to show, yes. I couldn't have just said theta and calculate theta using A1 without qualifying that A1 and theta are the same. So also keep that in mind. Write your statement with reasons. Don't use anything that you have not qualified yet. So also do your write-up as nicely as possible. Right. Then now the last question was saying to us, 3 straight lines, A, B, R, S, and X is equals to 3 intersect each other. The equation of AB is 3x plus BY is equals to -2. With B cannot be equals to 0. And the equation of RS is equals to, or is Y is equals to -2 over 3x plus 2. Now they say to us calculate the value of B. So usually in analytical geometry, it's very nice if you use diagrams without not much of imagination, right? So we have the one line has been said to be Y is equals to -2 over 3x plus, let's see, plus 2. So I know that is a decreasing function because its gradient is negative. That's how I know. So I think they said this is RS. And then we have another line. So we have this one, RS, I've already drawn. We have the line AB, which we do not necessarily, okay, at this point, we cannot clearly see what's happening because you can see how it's written. So we have to put it in standard form. So this, if you put it in standard form, it's going to be dy is equal to -3x minus 2. Because we're taking this to the other side, right? And you divide everything by b because we want to remain at y. So therefore the equation will be y is equals to -3x over b minus 2 over b. So this is basically showing us now that most likely, we're not sure, but most likely the gradient is a negative. And the reason why I'm saying we are not sure if the gradient is negative is because we don't know the value of b. Because if the value of b is a negative, the gradient will be positive. But if the value of b is a positive, then the gradient will be a negative. But at this point, we're not even worried about that. We're just going to say, let's assume it's a line like this. Because at this point, it's not important how the line looks, but it's understanding that the 3 lines intersect or touch each other. Right? So now this is what we are worried about at this point. Let me just erase. Why is it not drawing nicely now? Why is it creating this breaks? Oh my gosh. Okay, let's say this is a nice line because this pen is acting up for some reason. So we know that this is y is equals to -3 over b minus -3x over b minus 2 over b. I think we said that. Yes, minus 2 over b. So now we have a third line, which is a vertical line, I think. Let's check again, because remember it's 3 lines. There's also this line, which is x is equals to -3. And that line is a vertical line. How do I know it's a vertical line? Because it's sitting exactly at x is equals to 3 like this. And I think I tried to explain that to you guys last time when I did horizontal distance, vertical distance with you, and horizontal distance. So we have the third line. The third line is just like this. Let me just use a different color so that you can see. The third line is a line like this, which is vertically straight downwards. And then these are the 3 lines that we are having, and they're intersecting each other. So the question says to us, we need to figure out what is the value of B, right? And now we can see that these 3 lines are sharing this point. This is the common point, which we call the point of intersection of the 3 functions, right? So because they are intersecting each other at that point, it means that that point is existing for all the 3 lines, meaning that that point can be explained or governed by all 3 equations, right? Automatically, we know that this is going to be 3 is to something. We might not know the y value, but we already know the x value of the point. How do I know the x value of the point? Because the point is sitting directly on the line x is equals to 3. So its x value is going to be 3, right? Now, if I know the x value of the line, I can determine its y value using this equation if I wanted, right? I could also determine its y value using that equation. But the thing is, that equation, I don't have the value of b. That's why it's going to be very difficult to calculate the y value using the other equation. So rather, I would use this equation because I have everything in this equation. According to this equation, y is equals to negative 2 over 3 x plus 2. The y value should be equals to negative 2 over 3 multiplied by the x value, which is this one, that's the 3, plus 2. Therefore, y is equals to, these cancel each other, negative 2 plus 2, which says that y is equals to 0. Is there anyone who's confused with what I'm doing on the screen? X equals, someone is saying, isn't x equals negative 3? Oh, yes. Oh, my gosh. Right. It's negative 3. Thank you so much for noting that. It's not positive 3. So this is going to be rather a positive 2, and this is going to change to be a 4. Thank you so much. So x is not 3. It's not positive 3. It's negative 3 right here. Yeah, so whole thing up and down. So x is equals to negative 3, not 3. And then same method though, you substitute the negative 3, and you're going to get that that is going to be a positive 2 plus 2, which is 4. So therefore now we know that this point right here is 3 is to 4. Right. So if we now know that point is 3 is to 4, we can substitute it into this equation in order to solve for p, right? So we can say that y is equals to negative 3x over b minus 2 over b. That's the equation. Now we substitute the point 3 is to 4 because it's also a point on that line, which means that it's also governed by the same equation. Y value is 4, which is equals to negative 3 into the x value is 3 over b minus 2 over b. Simplify that. This is going to be 4 is equals to negative 9 over b minus 2 over b. So now we are saying these two have a common denominator, so I can basically take one denominator and say negative 9 minus 2 divided by b. And then this is going to be equal to 4 is equals to negative 9 minus 2, that's negative 11 over b. Cross multiply, this is going to be 4b is equals to negative 11. And then divide by 4 on either side. That is going to give us b is equals to negative 11 over 4. Are there any questions? Is there anything that is not clear with what I've just done on the screen? So basically, it's understanding that if 3 lines intersect each other, right, they're going to share the same point. The point of intersection is going to be a point on all 3 lines, right? So by understanding that, we do get the fact that the x value of this point is 3, which is negative 3, sorry. The x value of this point is negative 3. Why? It's because the point is sitting exactly on this line, and this line is governed by x is equals to negative 3. So x is equals to negative 3 means that any point on this line will have the same x value, which is 3. So that's why that point also has negative 3 as its x value. We don't know the y value, but we have the equation of the other line, which is also passing through the same point. So we can calculate the y value using that line, which is what we did here, right? Substituting that x is equals to negative 3, we find out that y is equals to 4. Now, once we have the coordinates of this point, we can substitute that point into the equation that has b, because now the only unknown in that substitution will be b. So if you substitute that 4 is equals to y, and then you substitute x as 3, as negative 3, oh, again, I substituted a 3. So it's a negative 3, so this is a positive 9, and this is a positive 9 minus 2. Oh my goodness, why am I bad with signs? Right, so this is going to be 7. Cross multiply, this is going to be 7. Right. Maybe let's just start here all together. So I said I made a mistake. This is a negative 3, not a 3, the value of x. So 3 times 3, that's 9, which is going to be this positive 9. And then minus that 2, which is going to be 7, right? So 4 is going to be equals to 7 divided by b. Cross multiply, that is going to be 4b is equals to 7. Then divide by 4, divide by 4, b is equals to 7 over 4. And that's the answer. Any questions? Are you all fine? I'm not seeing any thumbs up or down. So I don't know what to think. Okay. Now that is it for this question. Now, are there any questions regarding anything in analytical geometry? Because now I want to start a new section. Unless there are questions. Do you have any questions regarding analytical geometry in grade 11? Okay. So if I'm not, or on this question specifically, maybe, if there are any questions with regards to this question, you can also ask, then I'll attend to that. But then now, if there are no questions, that means I get to start the new section, which is supposed to be functions, right? Let's just look at my lesson plan and make sure that I'm going with it. Right, cool. So again, remember that you'll be tested on graphs, which are also known as functions, right? No, this is not what I'm looking for. Right. So remember already we had started with this because we're looking at a straight line function. So what we're looking at in analytical geometry is a straight line function, right? Just to remind you. So we have a straight line function. Just do this. So under functions, right, we have a straight line function. A straight line which is governed by y is equals to mx plus c. This we've already done together, right? That's part of analytical geometry. And now, continuing from this, we need to do what we call quadratic functions. So we need to do a quadratic function, which is also known as a parabola or a parabolic function. And this is governed by y is equals to ax squared plus bx plus c, or y is equals to a into x plus p squared plus q. Now explain all of this, don't worry. Now the third function that we need to do is a hyperbolic function. Which is governed by the equation y is equals to a over x plus p plus q. Then you need to also do an exponential function. Which is governed by y is equals to a b into x plus p plus q, where now we work with b must be a positive number and cannot be equals to 1. And then that. Then after that, we need to do quadratic, not quadratic functions, trigonometric functions. Which are your sine graph, cos graph, and tan graph. So you can see how much work we have to do. So that's why I might have to use facilitated sessions as actual online or live sessions, or I might have to squeeze in some things during the week. I don't know, but we need to find a way to work through this because this, as you can see, is a lot of work. And again, it'll be pointless to rush you through everything because it's no use if you don't understand these things. So let's try it again today to see how far we get with, we're going to start with the quadratic function, which is a parabola. Right, so there are a few things that you need to understand around a quadratic function or a parabola, right? So let's start with that. So quadratic functions, as I said, so the equation of a quadratic function can be written as y is equals to ax squared plus bx plus c. I'm going to start with this one before I show you the other one, because I can also write it as y is equals to a into x plus p squared plus q. Right? So now let's start with this one on this side. Right? So we say one. Let's discuss the parameters, right? Parameters, we're going to start with A. What does A tell us? A tells us the shape of the graph. We use A to determine the shape of the graph. How does the graph look of the graph, not quadratic? So for an example, if I have a smiling graph like this, we know that A must be greater than 0. If I have a graph that is not happy, like this one, that is sad, we know that it means that A was a negative number. Why is this line breaking? Right, so if A is a negative, I'm just also going to write so that you can see. So this is for A is a positive, this is for A is a negative. We know that if the value of A is a positive number, you're supposed to be having a smiling or a happy function. And then if the value of A is a negative, you're supposed to be having a sad or a concave down function. So we know that this is concave up and this is concave down, right? That's what A tells us. And then B, at this point, it's not really important for you guys to understand what B tells us. But if you are interested, B tells us how wide or like how, yeah, it tells us how wide or narrow the graph is. So if it's the value of B is much bigger, if it's a really wider graph, it's not so big if it's a less narrow graph. But I'm going to show you that. But at this point, understanding B is not really an important part of the station. But then now C, which is very important, tells us the y-intercept. So C tells us the y-intercept of the graph. So it tells us where the graph cuts the y-axis. That's what C tells us. And then now, if you understand that, that's the first part. Then for these graphs, we have what we call a turning point. A turning point is basically one, you need to remember that it's the point on the graph where the gradient is 0. So the gradient is not changing at the turning points, which is right here. These are turning point. It's the point at which the gradient is 0, 1. And also, what you need to know about the turning point is that it's the point where the graph changes its gradient from being negative to positive. So if you can have a look at this graph right here, you can see that you start with a negative gradient, but then when you get to the turning point, the gradient now changes and becomes positive. Similarly, on the other side, you start with a positive gradient, which is an increasing function, then it changes to becoming a decreasing function. So you need to understand that that is what happens at the turning point, right? Now, how do we calculate the coordinates of the turning point if you are given this? If you're given the function like this. So we are saying for you to calculate the coordinates of the turning point, you must use the equation x is equal to negative b over 2a, which basically tells us or gives us the maximum, right? Some people prefer completing the square, but it's really not necessary. Some people prefer completing the square to find both the x and y values, but I feel like it's easier if you do this, where you find the x value of the turning point. Then once you have the x value, how you're going to find the y value, right? Is by substituting into the equation. It's by substituting back to the original equation. Which equation am I talking about? for an example, this equation, right? So if you have the x value, you're going to come and substitute it right there, and then you're going to find the y value. Because remember that a turning point is also a point on the graph itself. So you can basically also think about that. Now, we are saying, what else do you want to talk about? If you want to find the x-intercept, it's the same method. For us to find x-intercepts, similarly, if you want to find the y-intercept, you get x equals to 0. That's basically that. So those are the parameters on a quadratic function that you need to understand. If you are given it in this form, those are the parameters. First things first, the A gives us the shape of the graph. It tells us what that is. It tells us whether the graph is a concave up function or a concave down function, one. And then the value of, so as I had explained, if you have a positive value of A, that automatically means that it's a concave up function. So it's a smiling face. If A is a negative, it tells you that it's a concave down function, which is facing downwards. The value of C is giving us the y-intercept of the function itself. Then you should also be able to calculate a point which is known as the turning point. So the turning point, as I said, it's the point where the function changes its the gradient changes its sign. So it moves from having a negative gradient in this case to a positive gradient, or it moves from being a positive gradient to being a negative gradient, right? Also know that at the turning point, let me write here, we're saying sign of the gradient changes, right? Or the gradient is equal to 0. Because the examiner can ask you to calculate the coordinates of the turning point using this terminology. So the examiner can say, calculate the coordinates of the point where the graph of f, the gradient of f is 0, right? So you know that the gradient of f is 0 at the turning point. So basically what they are saying is calculate the coordinates of the turning point. So that's why I need you to know this. And then how do we find the coordinates of the turning point? If we're given the equation in this form, we are determining the coordinates of the turning point by saying x is equal to negative b over 2a. Basically, this is an equation to determine the maximum or minimum, right? Remember, we know that our turning point is a minimum because it's at the lowest point in this case, but in this case, it's at the maximum. So it's the maximum point, right? So that's how we use the words minimum, maximum, and etc. So that's the turning point. For you to find the x value of the turning point, you need to use this equation if you are given the equation in this format. And then now, for you to find the y value of the turning point, what you basically do is that you substitute the value of x. You substitute the value of x back to the equation. For you to find x-intercepts, again, you let y be equals to 0. For you to find y-intercept, you let x be equals to 0. And that's the general idea. Now, are there any questions regarding what I've said on the left-hand side? Thumbs up if you're fine. Like you understand what I said. Okay, on the right-hand side, again, this is still a quadratic function, or this is still a parabola. But then now, the way in which the equation has been written is different, right? It's different for a reason or for a purpose. So if you are given in this the equation in this manner, there are only a few things that change, right? One, this doesn't change. A is still showing you the shape of the graph. So A still talks about the shape. It still tells you the same thing. It tells you whether you have a concave down function or you have a concave up function. We are still saying that if A is less than 0, which is negative, it's going to look like that. If A is positive, it's going to look like that, right? That does not change. Now, P and Q are basically talking about the turning point, right? So we are saying that the coordinates of the turning point are written as negative P is to Q. So if you know the code, if you know the value of P and Q, you basically just change the sign of P to find the X value of the turning point, and then you write Q as it is, which is going to be the Y value of the turning point. So we're saying X value, we're saying that is negative P, Y value, that is Q. So that's how you would determine the coordinates of the turning point if you're given the equation in this manner. You wouldn't have to use this equation right here, right? So that's the sort of like only difference. What else is different? Nothing. That's just those are the two things that are different. So it's very important that you understand the parameters, because if you understand the parameters, oh my gosh, let me just do this. Right. So if you understand the parameters, it's very much easier to then now understand anything about that graph. What else did I want to say? Yes, this is just generally how or what you must understand from a quadratic function, which is also known as a parabola, because you'll be required to determine the equation of a parabola, and you'll also be required to use an equation to determine anything else. Now, I can say determine the equation, or I can say use the equation to determine any other point on the graph or for anything else. So our focus right now, I'm thinking, should be in determining the equation, so that I'm seeing if you guys are comfortable with that. Then once I can see that you're comfortable with determining the equation, then we can move on to other things like finding the coordinates of this and that and that. So now let's make an example. Let's say you have, right, let's say you have a function. Actually, I think, let me just do this. I think the first thing that you must do is draw the graphs instead of determining the equation, yes. Because it becomes easier if now you understand how to draw. It becomes easier how to look at how to determine the equation. So now together let's look at draw. So drawing the parabola, right? What is it that you need in order for you to draw the parabola? Right. So let's say I give you an equation and I say to you, given that y is equals to x squared plus 5x minus 6. Then I say to you, draw the graph of that parabola given by y is equals to, let me just make it more interesting and say it's f of x. I say to you, f of x is equals to x squared plus 5x minus 6. And then I say to you, draw that graph. Right. So every time you get such a question, you need to think about a couple of things, right? So all the time, obviously, you are going to be, let me just show you the criteria for marking, right? So the criteria for marking always looks at what? One, we look at the shape of the graph. Is it the correct shape? Is it a parabola? Is it concave up, concave down, as it's supposed to be? And then obviously you're always going to have marks for the intercepts, right? Does your graph have x and y intercepts? Depending on how, usually they will give you a mark for the x-intercept and also another mark for the y-intercept. So the last mark usually will go to the turning point. Again, this depends on how much you have to work to get these things, but generally, as I said, the marks will range. But all the time, when you are looking at, why is this pen not writing anymore? Right. So when you are looking at a graph, these are the things that must come to your mind every time. You must think about the shape of the graph. It will have a mark. You must think about the intercepts. They will have a mark. You must think about the turning point. It's also going to have a mark. Then now, these are the things that you need to do for this function, right? So first things first, we need to think about the shape. So how is the shape going to look like in this case? We know that the value of a is 1, right? How do I know that the value of a is 1? We can see from the equation, there is nothing here, which means that there is the hidden one that you can't see. So the value of A is 1, which means that the value of A is greater than 0. Therefore, is this going to be concave up or concave down?
Concave up.
It's going to be concave up, like this, right? So we know that our graph is going to be concave up. Now, we need to determine the intercepts, right? So let's start with the x-intercepts. Let me use a black pen. Right. So now we are saying that for the x-intercepts, we know that y is equals to 0, right? So it means that this is going to be, since we know that this is f of x is equals to x squared plus 5x minus 6. This is going to be 0 is equals to x squared plus 5x minus 6. We can use the quadratic formula to get to the answer quicker. Negative 5 plus minus the square root of 5 squared minus 4ac, all that divided by 2a. So what are the two x values that you're finding from this calculation? Anyone?
Positive 6 and negative 1.
Positive 6 and negative 1. Thank you so much. So it means that our x-intercepts are going to be at 6 is to 0 and at negative 1 is to 0, because we know that for the x-intercept, y is equals to 0. What is our y-intercept? Do we need to calculate it? We can tell from the equation, right? Yes, it's negative 6 because I said to you the value of c, which is the constant, which is negative 6 in this case, it's supposed to be giving us the y-intercept. So the y-intercept is negative 6. If you liked, you could have substituted 0, 0. That would still give you negative 6. All right? So you can show the calculation if you want. If you don't want to, you don't have to. So we know that y is equals to, that is going to be 0 squared plus 5 times 0 minus 6, which is negative 6. And therefore, our y-intercept is going to be at 0 is to 6. Remember, the y-intercept, it's the x value that is equals to 0. That is why you can see here x is 0 and y is that, which is negative 6. Why am I saying 6? Which is negative 6. Right. So now, there's only one last thing that we need to determine before we can move on to draw the graph, which is the turning point. What is happening now? Okay. Let me just erase this. So this is going to be 0 is to negative 6, like that. Now, I need to determine the coordinates of the turning point, right? How do I do that? Do you still remember what I said? Anyone? So I said we use the equation x is equals to negative b over 2a to find the x coordinates of the turning point, right? So substitution, what is the value of b according to this equation? Remember, we know that this is a, this is b, and that is c. So that's 5. So this is going to be negative. You substitute the 5 divided by 2 multiplied by, what is the value of a?
1.
It's 1, right?
1.
So now if you punch that on a calculator, negative 5 divided by 2, that's going to give you negative 5 over 2. That is going to be the x coordinate. Now we need the y coordinate. Y is equals to, our equation is x squared plus 5x minus 6. So for us to find the y value, we are going to substitute the x value in the original equation, right? This is our x value right here. So substitute that, that's going to be negative 5 over 2 squared plus 5 multiplied by negative 5 over 2 minus 6. And therefore the y value of the turning point is going to be equal to
Negative 21.
negative 21. Thank you for that.
No,
Therefore, sorry,
ma'am, no, it's not correct.
what is it?
It's negative 49 over 4.
Okay,
I
thank you.
forgot to square.
No worries. Thank you so much for letting me know. Negative 49 over 4. Thank you so much. You said it's negative 49 over 4, right?
Yes.
Okay, therefore it means that the coordinates of the turning point are going to be negative 5 over 2 is to negative 49 over 4. Right, so this is telling us that our turning point is on the negative x-axis and also the negative y-axis. Which quadrant is that one? Let's check if people remember. Which quadrant is the negative x-axis and the negative y-axis? It's the third quadrant.
3.
Perfect. Quadrant number 3, right? So we expect our turning point to be in quadrant number 3. So now let's draw our graph in this space right here. So you're going to have your axis like this. And then, oh, I hate this breaks in this line. Another one, I'm sure. Right. Try again. There's another break. Oh, my gosh. Okay, let's do this. Okay, so now we are going to have one. We know that the line is a concave down graph. And we know that the turning point is on the negative x and y axis. So the turning point is somewhere on this side in the third quadrant. We said that negative 6 is our thingy. Let me just draw it in a different page so that it makes more sense. Let's draw it here. So you're gonna have this, and you're gonna have something like that, and then we're gonna have that. Now our turning point is on the
Ma'am,
yes.
is it concave
Oh,
up
sorry.
or down?
Sorry. Yes, I see what I did. I don't have x-intercept anymore. It's concave up, sorry, not down. Like this. I was wondering where my x-intercepts are at now. Thank you for picking that up. It's not gonna be perfect because of this breaks. Let's try and move it like that. Yay, it worked. Now, yes, thank you for that. This is gonna be 0 is to negative 6. This will now accommodate our x-intercepts, and this is gonna be our turning point. Negative 5 over 2. Negative 5 over 2 is to negative 49 over 4. Like this. Then our x-intercepts, we calculated them as 6 and negative 1. So obviously this one has to be the 6 is to 0, and this one has to be the negative 1 is to 0, which obviously doesn't really make much sense, but you can see, right? Let me just check here. So then now, when someone marks your graph, they're going to do this. They're going to say 1 mark for S, which is the shape. They're going to say 1 mark for both x-intercepts, and they're going to give you 1 mark for the y-intercept, and they might actually give you 2 marks for the coordinates of the turning point. So it's around about a 5-mark question. So generally, if I say to you, sketch the graph of f, this is what I would want you to do. I would want you to remember that everything that you do here, no one is going to really mark it. But it's also important that you do it because it leads you to this drawing. Usually what happens is that the marker is going to mark your graph. So it's very important that you get your graph right, because it's the one thing that is going to be marked. Your calculations on this side, no one is going to really care, but I care because they're going to help you get to the right answer. And then the person is just going to be marking this. Is there anything that is unclear?
Ma'am,
Yes.
can you please go up a bit to where we were looking for the x-intercept.
To where we're looking at
The x-intercept.
here.
Ma'am, isn't the 6 supposed to take the negative sign?
It I don't know who calculated this, but they said it's 6 and -1. Let me just can you
Because
punch
I get a 1 and a -6.
really?
Yes, ma'am.
Can you all please punch and check? Right. So yes, thank you for that. I'm getting that also when I punch my calculator. Please pay careful attention to sign H. Don't be like me. I am very not so good with signs. This is gonna be -6, and this is gonna be -1, and then
A positive 1.
right, yes, a positive one. Sorry, and then this is gonna be a positive 1, and this is gonna be 1 is to 0, and then this is gonna be -6 is 0 0. That time my graph wasn't making really much sense with regards to how can I this be okay, but either way, this is gonna be -6, and this is gonna be 1, and then that's it. Thank you so much for picking that up. Guys, please let's all punch calculators when we're calculating, because you can see that if one person does the calculations, it's more chances of error, including me. So please let's all punch calculators to make sure that everything is correct. Right. Generally, as I said, this is how someone would expect you to determine to draw the graph of a parabola given the equation. So I just give you the equation and then you draw the graph. Are there any questions regarding that? Is there anyone who doesn't understand how do we get to draw this? Okay, we're all fine. Right. Now, let's write. Let's see if this, okay, I just want to say something. So now, if I have this graph right here, I can write y is equal to a into x plus b squared plus q. Let's say I have an equation. Okay, let me just do another one on this side. So let's say I give you an equation, y is equals to 3 into x minus 4 squared plus 7, like this. And then I say to you, determine or draw the graph. Draw this graph. Yeah, because remember, that's what we're looking at. We're looking at drawing the graphs. You need to firstly get comfortable with drawing the graph before anything else. So now, I said to you guys, if the graph is given in this format, you need to remember that this is basically telling you about the turning points, right? So at this point, or in this case, the first thing that we can calculate is the coordinates of our turning points, right? So our turning points, what are the coordinates of the turning point? By reading from the
0.7.
Sorry?
It's 0.7.
Perfect. So it's 4 is to 7. So those are the coordinates of the turning point. And now, can I clearly see my y-intercept here? No, because remember we said you can clearly see a y-intercept only in this equation, which is represented by c, right? In this one, we need to substitute. We know that y-intercept, x must be equals to, like this. So this is going to be y is equals to 3 into, substitute 0 minus 4 squared plus 7. Therefore, you're going to find the y-intercept. What is the y-intercept?
55.
55. I'm also getting 55. Thank you. So therefore, the y-intercept is going to be 0 is to 55, right? These are the coordinates of the y-intercept. Now we go to the big guns, the x-intercepts, right? We know that for x-intercepts, y must be equals to 0, right? Now we are saying, I think I forgot this. The first things first was to talk to you guys about the shape, right? What is the value of a?
3.
3.
Which is
Concave
so
arc.
what is going to be our shape? Here, someone has already said it. Our shape is going to look something like this, which is a concave arc shape because it's a positive value of a. Now back to the x-intercept. Given that equation, y is equals to 3 into x minus 4 squared plus 7. Substitute y as 0, which is going to be 3 into x minus 4 squared plus 7, right? And now how do I solve for x? We can take the negative 7 to the other side. Oh, someone says I must slow down. Sorry. This is going to be equals to 3 into x minus 4 squared, right? I did not do anything much. I just moved the, to the other side. That to the other side. I moved the 7 to the other side. Up this other side. And then now you have negative 7 is equals to 3 into x minus 4 squared. And then now this is going to be divided by 3 on both sides. Divide by 3 like this. And you're going to have negative 7 over 3 is equals to x minus 4 squared. Which tells me that this graph of mine does not exist because you can't square root a negative number. So this graph was coming from my head, guys. So that's why it's impossible. But a graph that exists will be possible to square root on both sides. So in case you don't understand what do I mean by that, let's just assume. Let's assume this number was let me put a nice number like 36, right? Now at this point, I would have had to say what is the square root of 36, and on the other side, what is the square root of that? Don't forget that the moment you square root something, it's going to be plus minus, right? So the answer here would have been plus minus 6, because that's the square root of 36. Don't remember that this has nothing to do with this. I'm just saying because I had created this question from the top of my head, which is non-existent, I'm just choosing to put a 36 there to make things make sense to you. So this is going to be the plus minus 6 is equals to x minus 4, right? So the plus minus 6 is already telling you that you actually have two values of x, right? Because if you take the 4 to the other side, you're going to have plus or minus 6 plus 4. Because this, when you take it to the other side, it's going to be plus 4, which is equals to x. So what is this saying to us? This is saying to us x can be positive 6 plus 4, or x can be negative 6 plus 4. Because remember, you have a negative and a positive 6. So this tells us, when we read this entire thing, it's telling you that x is equals to positive 6 plus 4, or it's equals to negative 6 plus 4, which would have been x, or x is equals to, this would have been a negative 2. And our x-intercept would have been 10 is to 0, and this one would have been negative 2 is to 0, like that. So the only thing that makes it not make sense in this case, as I said to you guys, because these figures come from the top of my head, and this negative 7 already tells us that no, actually no, this can't be happening because you can't put the square root of a negative number. That's what I'm saying. But here I just wanted to show you the procedure or the method so that you understand that, okay, if it was actually a positive number and this was a true graph, you would have said the square root of either side. So the square root of 36 is a plus or a minus 6. So there are two numbers in there. It's not just a positive 6. There's also a negative 6, which is equal to x minus 4. Then that will give you this, which would have said to us positive or negative 6 plus 4, right? Which means that you actually have two x values. You have the x value where 6 is positive, and the x value where 6 is negative. The 4 is always positive because it only has one sign. So that's how we ended up with x is equal to positive 6 plus 4, or x is equal to negative 6 plus 4. which gave us x equals 10 or x equals -2. Then those would have been your x-intercepts. Then you can therefore sketch the graph from there. Now, I just want to check if there are any questions. Are there any questions regarding that? Thumbs up, thumbs down. Guys, give me an idea of where your mind is at. Okay, so similarly, if you know, right, if you therefore know how to determine the equation of a parabola, you should therefore be able to also use, sorry, not determine the equation. If you now know how to draw the graph of a parabola, given the equation, you should also be able to use a given graph to determine the equation of a parabola. Like, for example, if I give you certain things and then say you must determine the equation, you should be able to do that. So the first things first, as I said, for all graphs is you being able to determine being able to draw the graph, which you just did right here. I would give you the what is that? The equation of the graph, and then from the equation you should be able to determine these things: your shape, your intercepts, your turning points, and then also therefore drawing the graph. Don't forget this criteria. It's a very important criteria because this is how your graphs are marked, right? So now remember we said that there are two forms in which we write the equations of parabolas. So you should be able to understand the parameters of both. So if I give you a parabola that has been written in this way, or if I give you a parabola that has been written in that way, where is it? Yeah, in this way. You should be able to understand what is it that I get from a parabola that has been given as y is equals to ax squared plus bx plus c. What is it that I get from a parabola that has been written as y is equals to a into x plus p squared plus q? Very important to understand. Then the last thing that not the last thing, but one thing that I'm also going to talk about while I still remember it, but you're also going to visit it later, is understanding that a parabola has an axis of symmetry, but we never really talk about it. Just to show you an example. So if this is my turning point, if this turning point is maybe 3:4. So we have an axis of symmetry, which is basically a line that cuts the parabola in half like that. And then it makes the parabola symmetrical. What does it mean when I say it makes the parabola symmetrical? So when I move from this side to, why is this breaking again? So when I move from this middle point to that point, it should be the same thing as moving from the same middle point to that point. You will see how we use that to determine some of the points sometimes. So basically moving from that axis of symmetry to one extreme end is the same distance as moving from one extreme end to the other. And that is why the other way in which we determine the coordinates of the turning point is by taking x-intercepts and dividing them by 2, the x coordinates. Let me show you. So how we would determine, which graph did we draw now? Okay, I think it was right down there, right? So for example, let's say an examiner gives you this graph, right? If they give you this graph and say to you, let's say they did not give you this is not given, right? So if they say to you now, determine the x coordinates of the turning point, we can determine the x coordinates of the turning point by adding the x values of the x-intercepts and dividing them by 2. And now, why do we do that? I said to you that the midpoint, the turning point is the midpoint between any 2 points on the extremes of the parabola. So think of this as a line like that. Let me show you with a different color. Think of this as a line like this, right? And then the axis of symmetry of the parabola, which is this dotted line. The axis of symmetry of the parabola, think of it as cutting that line into 2 equal halves. So it's cutting it like this and like that, right? So it's like basically determining the x value of the midpoint, right? You take the extreme 1 plus extreme 2, you divide by 2. So that's how we can do it. But remember one important thing. You only do this for the x coordinates. You can't do it for the y coordinate, right? Because the only thing that is dividing, the turning point is dividing that line, which is a horizontal line, right? So you don't do it for the y values. Please, please, please don't forget that. You don't do it for the y values. You only do it for the x values, right? So I'm just going to write it somewhere where I say determining the coordinates of the turning point. So we can also say, no, it's not the y-intercept. Yeah, turning point, right? We can also say for the turning point, right, you take x-intercept number 1 plus x-intercept number 2 and divide by 2. That is going to give you the x value of the turning point. Don't forget this. So the x value of the turning point, you take the two x values of the x-intercepts, you divide by 2, and that should give you the x value of the turning point. This is a very important thing to know because it just helps you to calculate the x coordinate of the turning point if you are given the graph and you don't have any other means of calculating the turning point, but you have the graph itself. So if I give you a graph and you can see the x-intercepts on the x-intercepts of the graph, you can basically calculate the x coordinates of the turning point from there without even having to think much about it. Right. So so that's why it's important to understand to understand the axis of symmetry as a line that is basically cutting through any line segment made by any 2 points on the same extremes. And then what else did I want to say about the turning point? So say for example, this is the line 5:7, and then this one has to be, that can't be that. Okay, just do this. Okay, let me just make this -1 because it's not going to make sense why there's a -5 on the left hand side. Right, so let me just make it like this. So if you see, moving from this to that, that's basically saying -4. So it's 4 units to the left. So that also should be 4 units on that direction. So this is 4 units in that direction. This should be 4 units in that direction, which is going to be 7:7. So it also helps you to calculate coordinates of other points if you know that they're on the same y value. So for example, in this case, I know that these 2 points are on the same y value because the y values are both 7s, right? So it means that their x values should be symmetrical along the turning point. What do I mean by that? If moving from the turning point to one point, in this case, moving from the turning point, which is that x is equal to 3, to that point, it's minusing 4 units because we end up at -1. It means that moving from the same midpoint to the other side should also be 4 units, but now it's an addition, right? Because we know that according to the Cartesian plane, moving to the left is a subtraction, moving to the right is an addition. So when you go to the right, it's an addition of 4 points, which is ending at 7. These are just some other things that you should sort of like understand so that you can master interpretations of graphs. But don't worry, again, we're going to speak about this a lot again when you start interpreting graphs. Now it's important to understand the basics so that you can interpret the graph itself. Right. So that is that. So now the last few things that we're going to talk about, but before I go there, are there any questions with anything that I've said? I know it's a lot to take in, especially since you first spoke about analytical geometry. But yeah, guys, it's not me, it's the content. It has to be pushed. So if there's something that you don't understand, yes?
I need to ask you something, but I just don't know if I'm gonna make sense.
Okay, let's try.
So, can you please go a bit up to the turning point form?
To the turning point, which one?
The one that we've been doing, you see the equation that you gave us that has 3 multiplied by,
This
I
one.
don't recall. Yes.
Mhm.
So I need to understand something about the value of P there.
Okay.
Yes, because on the equation it's written as a negative.
Mm-hmm.
So I need to understand that if the equation has a negative P value as in that equation, does it simply means that the turning point is at x is equals to a positive P value?
Yes. Yes, so that's what I was trying to
Oh,
indicate right here. Where I said, where is it now? Yes, where I said the x value of the turning point is negative p, and then the y value of the turning point is q, which basically tells us that every time you see the value of p, you change its sign to make it negative p, which is the x value of the turning point, and the value of q remains as it is as the y coordinate. Does that make sense?
yes, ma'am. Yes, ma'am.
Right.
Makes
So always
sense.
when you look at the equation in this format, just always know that when I want to write down the coordinates of the turning point, I change the sign of the number that is inside the bracket to find the x coordinate of the turning point. And then the y coordinate is just going to be q as it is. Are you fine?
Okay, ma'am. Thank you.
Right, no worries. So now, oh, this is what I was saying. So now, you should be able to determine the equation of a parabola. Right, there are multiple instances that will allow you to determine the equation of a parabola, right? Let's start with the simple one. So determine the equation where the examiner gives you, where the two x-intercepts and a point. For example, the y-intercept is given, right? So there are multiple scenarios in which an examiner can expect you to know how to determine the equation of that specific parabola. Let me just find a particular graph that I can work with, because if I create my own graphs, they become non-existent. So let me just find, there's one that I actually have written down here. Okay, we can use the ones that we did above. So let's say, for example, I give you this parabola of mine. Oh, the line starts breaking again. Oh my gosh. Right, so let's say I give you a parabola like this, and I say to you, the x-intercepts of the parabola are, you have -6 is to 0, then you have 1 is to 0. Then I say to you, the y-intercept of this parabola is 0 is to -6. Then I say to you, determine the equation of this parabola. Remember, I said to you, this is scenario number 1. This is the scenario where they're going to give you the x-intercepts of the parabola. Let me show like this. So they give you the x-intercepts of the parabola and the y-intercept. Oh, okay, let's see. So how do I approach this one? Now, we are saying you need to know this. So when we determine the equation of this parabola, we will use this equation where we say y is equals to x minus x1 into x minus x2. Right, so we use this equation in order to determine the equation of a parabola that has the given two x-intercepts and any other point meaning that it could be the y-intercept, but it must be any other point on the graph. It cannot be the x-intercept again. So it has to be any other point. Keep that in mind. So we are saying, what do x1 and x2 represent? We say that this is where x1, why am I saying xi? This is where x1 and x2 are the x-intercepts, right? So x1 and x2 are our x-intercepts. We substitute them into that equation. So now let's make this one an example, right? So we say y is equals to a into x minus the first x-intercept that I'm going to substitute is the -6. So I'm going to substitute into -6, and then I'm going to say that into x minus my second y-intercept is 1. So I'm going to say 1. And then now I'm going to simplify this into y is equals to a into x plus 6 into x plus, sorry, it's minus, into x minus 1. Do you understand up till this stage? Do you see what I've done? I haven't done nothing much. So basically we're saying this is the equation that you use to determine the parabola if you're given or if you know the two x-intercepts, right? Again, only and only if you know the two x-intercepts, guys, because you can't use it if you don't know the x-intercept, because you need to substitute the x-intercepts, right? So you substitute the x-intercepts. That's what I've done here. Substituting the x-intercept, you substitute x1 as -6, which is the first x-intercept. You substitute x2 as 1, which is the second x-intercept. Then you simplify. So then now we're going to have this. Now you can see that there's a problem. We don't know the value of a, right? And that is where the next point comes in, or the other given point comes in, right? So here we need to substitute the given point, which is the y-intercept, which is raised to -6. Why do we substitute that point? That point gives us the value of a. So this is going to be -6, which is the y value, is equals to a into the x value is 0, plus 6, and then 0 minus 1. This will be -6 is equals to a into 6 into -1. -6 is equals to a multiplied by, what is 6 times -1? That's -6. We divide on both sides by -6. Therefore, we find out that a is equals to 1. We are not done determining our equation. We need to continue. Now, we are saying, let's just continue on this side. So we are saying we had y is equals to a into x plus 6 into x minus 1. This is what we had here before we got stuck because we did not have the value of a, right? This step was just to help us to calculate the value of a. Once we have the value of a, we are fine. So now we are substituting the value of a, substituting that a is equal to 1. So this is going to be y is equal to 1 into x plus 6 into x minus 1. This will be y is equal to x plus 6 into x minus 1. Because it's the same thing as ignoring the 1, right? Because everything is going to be multiplied by 1. Therefore, now you do your foiling method. We need to foil this times this. We're going to have y is equals to x squared. This multiplied by that, that's going to be -x. This times that is going to be plus 6x. Then this times that is going to be -6. Simplification, y is equal to plus 5x, because minus x plus 6x, that is going to be minus 5x minus 6. And therefore, that's your equation. So the equation is y is equal to x squared plus 5x minus 6. Then you are done. Are there any questions? Is there anything that is not clear? Is there anything that is confusing? Are there any questions, guys? Just take you through again. So if you are given the x-intercepts and any other point on the graph, how you determine the equation of the parabola is basically by using this equation. Why this equation? Because this equation allows you to substitute the x-intercepts that you have been given, right? So we said in that equation, x1 and x2 represents the x-intercepts, right? So we substitute our x-intercepts. The first x-intercept is -6. The second one was 1. I'm reading that from this graph, right? Reading that from that graph. Then now, simplification, I'm basically just saying minus 6, that's +6, minus 1, that's -1. Then now, at this point, I cannot continue to determine the equation because of this a, which is a problem. I need to find the value of a so that I can solve for the equation. So how do I find the value of a? That's where I substitute the other point or the next point, right? How do I substitute that point? Obviously, the y value is 0. Sorry, the y value is -6. The x value is 0. So after substituting that, I'm then going to solve for the value of a, right? 0 plus 6, that's 6. 0 minus 1, that's -1. 6 times -1, that's just -6. Then I'm dividing by -6 on both sides. Therefore, a is equals to 1. Now, once I've calculated that my value of a is 1, I need to substitute that a back to where I wanted to eliminate the a, which is here, right? So if you substitute back the value of a, you're going to find out that you have this. So you need to fill in x times x, that's x squared, x times -1, that's -x, 6 times x, that's 6x, and then 6 minus times -1, that's -6. Then if you simplify minus x plus 6x, that is going to be plus 5x. Then you get to this point. Then that becomes your equation. Right? Now, I just want to show this. Right. Okay. Before I show the next thing, guys, are there any questions? We have plus minus 10 minutes remaining in the session. So are there any questions? No questions. Are you sure? Yeah. Okay. Right. So the second part, or the second way, or the second scenario, we only have about 2 scenarios, right? The first scenario is when you are given the 2 x-intercepts and a point on the graph. That's scenario number 1. Then we have scenario number 2. Scenario number 2 is yes.
Can I please ask, by saying you can use that equation either when you are given 2 x-intercepts and a point, can it also be the turning point?
Yes, it can also be the turning point. It just has to be any other point other than the x-intercepts.
Okay, ma'am, thank you.
Because if you use the x-intercepts, you're not going to get anything because you've already substituted them. So it must be any other point on the graph. It also can be the turning point. But I'm going to show you why. I'm going to show you. Okay, I'm just going to talk about that when I get there, which is the scenario number 2. When you are given the turning point, life becomes a little bit easier because now, let me just draw this. Let's say you're given this graph right here. It's the same graph. Now, I'm not giving you the x-intercepts. I am still giving you the y-intercept. Let me just do this. I'm giving you the y-intercept. That's 0 is to negative. That's 6. That's 0 is to -6. And then I'm giving you the turning point as, let me see what it was. -5/2 is to -49/4. -5/2 is to -49/4. And I say to you, given this graph, let me just write here. We're determining the equation now, given the turning point and another point on the graph. Right. So now we are saying we want to determine the equation given the turning point and another point on the graph, right? So remember, initially we were given what? We were given the two x-intercepts and a point. But then now we are given the turning point and another point, right? So now for that one, we usually or most likely will have to use this one. Y is equal to x plus b squared plus q. Why am I using that? It's because that one allows me to substitute the coordinates of the turning point, right? This one allows me to substitute the x-intercepts. That's why it's most likely, it's a good one for when you have the x-intercepts. This one allows me to substitute the coordinates of the turning point. That's why you most likely will use this one, right? So first things first, what are we going to do? We're going to substitute the coordinates of the turning point. But don't forget that our coordinates of the turning point, in this case, we have negative 5 over 2 is to 49 over 4. That is also negative. Don't forget that this is negative p and this is q. So when you substitute it in there, you must also substitute it as negative p and q. What do I mean by that? This is going to be y is equals to, I don't know the value of a, into x. P is going to be that. So you're going to have p, which is 5 over 2 squared. So why am I not substituting negative 5 over 2 exactly? It's because we said that negative 5 over 2 is negative p. So you need to change the sign before substituting inside the bracket. Similarly, if I had given you this, you would have said the value, the x coordinate of the turning point is a negative. So you always change the sign in between what is inside the bracket and what is the x coordinate of p, or of the turning point, sorry. But then q is exactly as it is. Q is negative 49 over 4, right? We substitute it like that. Then now, what is the problem that we are facing here? Again, we have the problem of a, which we don't know. But we can calculate the value of a by doing what? By substituting the point that has been given to us. So again, we have been given the y-intercept, which is 0 is to negative 6, if I remember correctly. Right. So 0 is negative 6 is our y-intercept. So it's another point on the graph that we can substitute here in order to solve for a. So this is going to be the y-coordinate, which is negative 6, is equals to a into the value of x is 0 plus 5 over 2 squared minus 49 over 4. Right? What am I doing in this case? I'm going to take this and take it to the other side so that I have negative 6 plus 49 over 4 is equals to a into 0 plus 5 over 2, and that's squared. When I punch my calculator, negative 6 plus 49 over 4, that gives me 25 over 4, which is equals to, what is 5 over 2 squared if you punch your calculators?
25 over 4.
That's 25 over 4, thank you, a, right? Then we can divide by 25 over 4 on both sides. Divide by 25 over 4 before you find out that a is equals to 1. And now we can come back to this one. Since we have the value of a, we can therefore say our equation of y is equals to 1 into x plus 5 over 2 squared minus 49 over 4, which automatically is y is equals to x plus 5 over 2 squared minus 49 over 4. Is there anything that doesn't make sense on my screen? Are we fine? Guys? Okay, I'm saying thumbs up, thumbs up, thumbs up. Now, what is the other thing that is important to understand? This is the last thing that I'm going to be speaking about. Well, might not be the last thing, but yeah, think of it as the last thing maybe. Right. So we know, so we have calculated that our equation is y to x plus 5 over 2 squared minus 49 over 4, right? the examiner can say, leave your answer as y is equals to ax squared plus bx plus c. So they're telling you that, oh, okay, we can see that you've determined the equation using the turning point, but we want you to leave your answer as y is equals to ax squared plus bx plus c, which is the standard form. So that means now that your answer will not end here, but your answer will have to continue. Like you need to continue simplification. Now, this is going to look something like this. So you're going to have y is equals to, we know that x plus 5 squared is the same thing as x plus 5 multiplied by x plus 5, right? Which will be, in this case, it's going to be x squared plus 5 over 2 times 1, 5 over 2 times 2, that's 5, x squared plus 5x, plus this is going to be 25 over 4, and then minus 49 over 4. 5 squared, that's 25, right? Yes. And then now, this is going to be y is equals to x squared plus 5x. Then this is going to be 25 minus 49. And then this is going to be over 4 like this. And this is going to be y is equals to x squared plus 5x minus 25 minus 49. That is going to be, okay, I think I made a mistake somewhere here. Let's just do this to make life easier. So 25 over 4 minus 49 over 4, that's going to be negative 6. If you punch it on your calculator, so that's going to be negative 6. Therefore, this is going to be the equation in that form. So in this case, we're told that we must leave the equation in that form, in this form. So remember, we got to this point. This is the equation. Not that it's wrong, but in the examiner said you must leave it in this form. Leave your answer in that form. So you must just basically continue and simplify. How do we simplify again? Don't forget that if I say to you x plus 5 over 2 squared, this is the same thing as x plus 5 over 2 multiplied by x plus 5 over 2. I just don't do this because I have a faster way of doing it. And the faster way of doing it is basically saying you take the first term, you raise it to the power of 2. In this case, it's going to be x squared, which is x squared, right? Then you take the first term, you multiply it by the second term, and then you multiply that by 2. In this case, I basically said x multiplied by 5 over 2 multiplied by 2. And that is what gave me 5x. Then lastly, we take the last term, which is this obviously, and then you square that, which gave me 25 over 4. So I do this to go quicker, but if you don't want to go quicker like me, you can also like do this expansion of brackets and then work it like that. But generally, the easier way is you take the first term, you square it. You take the first term, you square it, and then you take the first and second term, you multiply them, and then multiply it by 2. Then you get the second answer. Then the third answer is basically taking the third term or the last term, not the third term, the last term, which is 5 over 2, and then you are squaring it. That is going to give you 25 over 4. Then you can continue. Similarly, where is it? Yeah. Similarly, given the equation like this, the examiner can tell you, if the equation is given like this, if they give you the equation like this, they can tell you, leave your answer in the form y is equals to a into x plus p squared plus q, right? So if you leave it in that, if you have to leave your answer like that, that's where completing the square comes in. Have you guys been taught how to complete the square? Have you done completing the square in grade 11 yet?
Yes, ma'am.
Okay, so you have to complete the square. I'm going to show you how I complete the square. So you have to complete the square. So basically what you do is you have y is equal to x squared plus 5x minus 6. So how you complete the square, you isolate the last term. So it's going to be y is equal to x squared plus 5x. This negative 6, you push it away. And then what you do basically is that you say, what is half of the middle term squared? So half of the middle term squared. In this case, my middle term is 5. So I would ask myself, what is half of 5? And that's squared. And I also need to subtract it, because remember, if you add it and don't subtract it, you are changing the value of the expression. So you need to add it and subtract it at the same time, like that, minus 6. But you don't have to show this. I'm just showing you so that you can understand where the numbers will be coming from. So this is y is equal to x squared plus 5x. The half of 5 is 2 over, sorry, half of 5 is 5 over 2. And then we say 5 over 2 squared, that should give you 25 over 4. So this is going to be plus 25 over 4 minus 25 over 4 minus 6. Like this, right? So you can see that whatever that I've added, I also subtracted it again so that I do not change the value of the expression, because it's very important that you understand that. So now we are saying this is going to be y equals to. Now how do I complete the square? So you're basically going to do this. So you're going to basically say this squared, obviously. And then you're going to have outside the, let me just do this. So you're going to consider the first 3 terms. Right, so you're going to consider the first 3 terms. So you're going to find the square root of the first term. What is the square root of x squared? That is x. You're going to put that inside the bracket. We're going to find what is the square root of the third term, which is 25 over 4. The square root of the third term, 25 over 4, is going to be 5 over 2, if I'm not mistaken. Yes. So it's going to be 5 over 2. The sign between x and 5 over 2 is going to come from the middle term. The middle term is 5. So the middle term 5 is positive. Therefore, this is also going to be positive, like this. And then outside this bracket, you're going to have negative 25 over 4 minus 6, which is basically everything else that is remaining after you've completed the square using the first 3 terms, like that. Then this is going to change to become y is going to be equals to, you're going to have this becoming x plus 5 over 2 squared. If you punch your calculator and say negative 25 over 4 minus 6, you're going to have negative 49 over 4. And therefore, we have completed the square and have written the equation like the way we were asked to in that form. So for this form, you need to complete the square. For the other form, it's just a matter of expansion and simplification. You saw how from here, where was the one? Okay, yeah. Here it was a matter of expansion and simplification. We just expanded. Here, we just expanded and simplified. But for the other form, you need to complete the square so that you can put it in standard form. Do we all see this? Are there any questions that you have? Right. So I'm glad if you understand. So what is it that you should be taking away from this session, because it's coming to an end? It's ending, actually. So you need to be able to draw the graph of a parabola given this format or the other format. So you need to understand the parameters. You need to understand the fact that A gives us the shape of the graph. You need to understand that for this format, the value of C tells us also the y-intercept. You should be able to determine the coordinates of the turning point using this equation, and also understand that it only gives you the x value of the turning point. The y value of the turning point can be calculated by substituting into the y value, into the equation, sorry. Everything remains x-intercept and y-intercept. We still say for the x-intercept, y must be equals to 0. For the y-intercept is x that must be equals to 0. That still remains. It doesn't change, right? Now then we are saying for the other form, you need to understand that it allows us to, again, see the shape of the graph. If A is positive, you get a positive function, which is an increasing function. And then if A is negative, you get a concave down function. Understand concave down and concave down. Concave down and concave up. And then P and Q tell us the coordinates of the turning point, but not directly, because the coordinates of the turning points are in the form negative P is to Q. So the x value of the turning point is negative P, the y value of the turning point is Q. So understanding that, you should be able to draw the graph. The criteria that we use to mark the graph is, one, it's the shape. You need to have a correct shape of the graph. Is it concave up, concave down? Two, you need to understand the intercepts. X and Y intercepts will be marked. Usually 2 marks for those. I think, yeah, usually it's 2 marks for this. And then for the, sorry, that's for the X, for the Y. Those are the 2 marks here. Then for the turning point, usually they will give you 2 marks. So that's that. So you should also understand that we do not only expect you to know how to draw the graph, you should also be able to interpret the graph, but we're going to deal with interpretation later. So now you also need to understand that when I'm giving you the graph, can you determine the equation? We said usually there are 2 forms in which the equation, they would expect you to determine the equation. It's either you're going to determine the equation when you are given the 2 x-intercepts on the graph and a point on the graph, which is when we use this format or equation, because it allows you to substitute the 2 x-intercepts, right? Then now, as we did here, then if you are given the turning point and another point on the graph, you use this format because it allows you to substitute the coordinates of the turning point and work your way around it. Remember that the reason why you need another point on the graph for both methods is because at some point you need to figure out or solve for the value of A, and you can only do that if you have another point on the graph to substitute. Then lastly, I was talking about the fact that since there are 2 forms in which a parabola exists, the examiner can ask you to leave your answer in this form, or they can ask you to leave your answer in that form. So you need to understand that if you need to leave your answer in this form, you just need to simplify things. To show an example, as I had already said, where is it? Right, for example, here we had our answer as y is equals to x plus 5 squared minus 49 over 4. So I can still expand this to simplify into that form, which is what we did here, until we got to this form. And then also understanding that the examiner can expect you to leave your answer in this form. And if you have to leave your answer in this form, that's where you complete the square, which is this part. You complete the square. And are there any questions? Right. I guess this then brings us to the end of the session. Thank you so much, guys, for joining the session. I really appreciate it. And again, sorry for making you join the grade 12 class. But yeah, I'm hoping that your analytical geometry is going well in terms of practice. If there are any questions, again, please feel free to ask, and I will repeat this. It becomes easier if you ask the question on the group, because if I can't see it, most likely someone will see it. But usually I move around the groups to check for questions. It's not easy for me to answer all your questions when you ask me individually, because sometimes, especially if you ask me the question first, if someone else then now asks a question after you, multiple people by the way, I'm gonna see their questions first, which is unfair, right? But like that's how WhatsApp works. I'm gonna see their questions first and answer them first before I can answer you. Sometimes I might not even get to answer it because there's just now a lot of messages up there. So please try to ask your questions on the group, and then usually I will see on the group because it's like a common space for everyone. So yeah, that's technically it. Good night, guys. Keep warm, please. It's very cold. Keep warm because you don't want to get sick for the June exams. You want to be extremely healthy. So yeah, please keep warm, guys, and I will see you tomorrow for our facilitated session, which I might change to a live session, but I will let you know what is happening before I change anything, because we're quite. You saw that we quite have a lot to get through. So yeah, good night, guys.